So, hello, good afternoon, good morning, or good evening, wherever you are. Welcome to next Elmarco Talks, the next series. Today we have a actually great opening of this series starting after summer holidays. Today is September, so we're starting right away after summer. My name is Katerina. I will be moderating this session together with my colleague Ivan Ponomarev as the Chief of R&D.
Hello, everyone.
All right, so let's see what we have to present on today's talk. The topic of today will be about the sustainable membrane fabrication by electrospinning. This topic will be presented by Professor Alberto Figoli. I will talk about Professor a little bit later. Before that, I like to promote next sessions, which are going to be happening still within this year by the end of 2025. We already prepared this planning. So October, there will be again, colleague of mine, Ivan, will be giving a presentation on environmental, ecological, and sustainable approach in electrospinning techniques. And then following in November, we have already reserved time for Elmarco colleague, Josh Marasco, and he will be presenting latest innovations for industrial electrospinning. So please follow us on our websites for some actual timing, but these times are already fixed. So now it's my great pleasure to welcome Professor Alberto Figoli. I know him quite well from all the membranes conferences and exhibitions, because wherever you go and there is a talk about membrane, then he's presented. Professor Figoli is an expert in the field of membrane technology, particularly in membrane preparation and characterization and application in environmental field. From his background, I read his experiences, and he started actually at University of Twente in Holland in a group of membrane technology group as a PhD student. I know this group is also very active in membrane development. The same is valid for a membrane materials and processes group located also in Holland in University of Eindhoven. So those membranes people are usually working together, and this board is very interesting, and I hope that this talk will bring you very interesting information from the membrane world. Before we start, I would like to give word to Ivan. He will present something more about Elmarco, just a couple of slides, and we will give then the word to Professor.
Thank you, Katerina. So let's go ahead. Talking about Elmarco, some numbers about us, and one of the main number for this year is 25th anniversary of our company. This is a list of our partners who are using our equipment. You can see that we are globally presented, and you all know that our technology is related to needleless electrospinning, so we don't use needles on spinning electrodes to deliver polymer solution onto it and to further electrospin it. In our portfolio, we have different pieces of equipment. NS Lab, which is supposed to be used mainly at universities for academic fundamental research, when you can easily move from this fundamental research towards NS3S, which is half-meter wide semi-production machine. If you're successful or volumes are not that big, you can work on 1 meter wide machine, NS4S, and if everything goes well and you need real industrial production, then you can go towards 1.6 meter wide machine, which is presented at the bottom of this slide. So main applications for nanofibers nowadays, it's obviously still air filtration, liquid filtration, perfoapparel, medicine, or let's say healthcare. energy acoustics. Today we are going to talk, as it was already mentioned by Kateřina, about membranes. So it's going to be more related to liquid filtration.
So now it's the time, Professor Figoli, it's your turn. So you can start sharing your presentation and start talking about your work. I just want to remind for everybody, please, even during the talk, you may use the Q&A session for your questions. And after the speech of Professor Figoli will be finished, we will spend about half an hour answering all your questions live. So please, everybody, enjoy.
Thank you very much. Thank you for the nice introduction. Thank you, Elmarco, for the invitation. It is a big pleasure for me to be here and share with you our latest development, and also to show what is the direction of membrane fabrication goes nowadays. Just briefly, let me give the chance to present my institute. My institute, which I have the honor to direct, is the Institute of Membrane Technology. ITM has been a structure created in 1993 by the National Research Council of Italy for development at national and international level of membrane science and technology. It is part of the Department of Chemical Science and Material Science Technology of CNR. We have the headquarters in Rende, which is located further south in Italy, in Calabria region. And we have also research unit at University of Padua in the north of Italy. Here you can see some of the picture of our labs, and in fact we are located inside of University of Calabria, which is really beneficial for us because we have a lot of interaction with other colleagues in different fields. CNR-ITM has a permanent staff at the moment of about 41 researchers, made by permanent staff and 4 temporary staff, 2 technologists, and 8 administrative technical staff. Everyone has to do with membranes. So our motto is no membrane, no party, something like just to show how we have growing up in our institute. So here I just show some of main activity of our institute. Thanks to the multidisciplinary and expertise of different background of the researcher we have in our institute, coming from biology, from food and chemistry, from chemistry, food science and technology, chemical engineering, chemistry, etc. We have the chance to apply membranes in really different fields. So not only water or liquid, which is traditional membrane technologies applied, but also in other fields. If we go a bit more in detail, we design the type of membrane we want to use, depending, of course, on the final application. So we have colleagues working on molecular dynamics and quantum mechanics. Then we go directly to produce a device, really membranes in flat configuration, in hollow fiber configuration, also even in capsule and beads configuration. This is a quite interesting tool that lately we have invested a lot also because there is a lot of requests coming from several companies. And of course, electrospinning machine and device entering in this category of flat sheet membrane in our case. And with support with Elmarco, we have developed a very interesting membrane for different applications. The membranes, once we have it, then we are using modules and then can be really applied in different area, from biotechnology, gas separation, and food and beverage, water treatment, desalination, in energy, and biomedical applications. So as you can see, membranes can really use in different fields. Going to the outline of my presentation, I would like to give a brief introduction on membrane science and technology, because I think the audience maybe today is a bit larger and many people talk about filters, and I would like also just to report some small differences between when we talk about filters and membranes. And then I will talk more in detail about polymeric membrane fabrication, the most used technique, an overview of non-toxic solvent biopolymer membranes, and then I will report a specific case study using a sustainable solvent for membrane fabrication using the Elmarco electrospinning laboratory setup DNS lab that previously you have been seeing. And then some briefly conclusion and then discussion. So just go to the definition. What is really a membrane? A membrane is an interface that selectively restricts the passage of different components in a specific manner and over a wide range of particle size and molecular weight from ions to macromolecules. The separation is regulated by transport mechanism, which is different by different type of membrane and process we are using. Here in this scheme figure, I just report a typical figure that report the common materials you want to remove, and based on their dimension or molecular weight, you can apply a specific type of technology. Usually, generally, if you have compounds bigger than 1 micron, you talk about particle filtration. If you go below 1 micron, let's say 5 micron below, you are talking about microfiltration. So microfiltration ranging is a membrane which has a pore ranging from 0.1 to roughly 5 micron. Ultrafiltration is a membrane with a smaller size dimension going from 0.01 to 0.1 roughly micrometer. Nanofiltration is going from 0.01 to 0.01, and then you go lower to reverse osmosis. Practically, we are talking of membranes which are practically dense membrane. Reverse osmosis is very familiar because it's the dominant technology at the moment in desalination for salt rejection, so to obtain pure water from seawater. I reported, and these membranes are related to the separation process, or reverse osmosis, nanofiltration, ultrafiltration, microfiltration, are pressure-driven membrane operations. So you have to apply a pressure to make your fluid pass through the membrane and separate the compound you want. Of course, there are other membranes that are known as gas separation, for example, separation, where you are in the range very close, very low, the reverse osmosis, so very dense membrane, where the separation is given by the selectivity of the species you want to separate with respect to the layer of your polymer that makes the selective membrane. There are also innovative membranes called membrane contactors, which is a membrane which brings in contact two fluids, for example, and usually allow to separate volatile compounds from the one not volatile. And you can get, for example, very high quality purified water. This is just to give you a brief an indication of what is a membrane. As I mentioned before, membrane, in particular polymeric membrane, this is the talk of my today, can be applied in different fields. Desalination is probably the main one, is related to the desalination of the water from the seawater, and reverse osmosis is the dominant technology in the field. Water treatment can be used different types of processes like ultrafiltration, microfiltration, membrane bioreactor, and can be applied really in different sectors from food and beverage and pharma. Medical application, you can think, for example, of hemodialysis, which is one also very interesting application of membrane in the medical field. Gas separation, I already briefly report, but for example, membrane can be used for production of biogas to purify methane from CO2, for example, or it can be used also in the energy field. Consider that all the key point of all electrolyzer, fuel cell, energy lithium storage battery are membranes. So as you can see, membranes can really play an important role in different applications. Just to give you some indication in square meter, in percentage, you can see that the most produced membrane are related to the hemodialysis healthcare, followed by desalination and water treatment, gas separation, energy, and then all the others. Briefly again, before going more in detail on talking about the sustainable membrane, the efficiency, the advantages of the membranes are mainly the efficiency and the operational simplicity, the high selectivity and permeability for the transport of specific components, the low energetic requirement, good stability, compatibility between different membrane operation. It can be easily integrated in the industrial processes. has a larger flexibility and easy scale up, and then advanced levels of automatization and remote control. Of course, all the membrane process, the heart, let's say, of each membrane process is the membrane itself. Related to the membrane, polymeric membrane, I just show how we produce usually membrane. Membrane are most of the time produced by so-called phase inversion technique. We start with dope and polymeric solution preparation. So we have a polymer, we add some additive if you want to create some pores in your membrane, and then you solubilize in appropriate solvent. When you have a very transparent solution, thermodynamically stable solution, you can start to prepare your membrane. The membrane can be made flat. For example, you just cast on a support, which can be a non-woven, or it can be just a dense film, and then you cast your membrane. Or it can be made in a hollow fiber configuration. So you have like a kind of we call, like, if you think of, for example, I'm coming from Italy, so like spaghetti, this gives you an idea how it can be the hollow fiber look like. Different than spaghetti, you have inside a hole, which allowed you to have inside the passage of the feed, for example, you want to treat, and then a passage through the membrane on the other side, on the outside of your lumen, you can get the purified compound. For this type of membrane, you allowed using this type of technique, you have the possibility to produce really different type of morphology: asymmetric, symmetric, porous, dense, just playing with the process parameter and some key factor like a choice of the polymer, choice of the solvent and non-solvent, composition of the casting solution, temperature of the casting solution, coagulation bath, and evaporation time. And usually there are kinetic factor together with the dynamic factor, which allow you to play and make it membranes that are or indicated and good for the specific application. Another membrane fabrication I would like also to report, and nowadays is growing a lot, is the membrane fabrication using electrospinning. Of course, probably there are a lot of experts connecting, that Elmarco is with us. The main configuration we know is the classic electrospinning configuration system. And then I have to say, I call Elmarco configuration, because I was very impressed the first time I saw what you are using the needleless technology. Very interesting, I think very powerful also if you want to scale up your technology. I think this is make quite unique in comparison to the classic electrospinning machine. I remember many years ago when I started and we are using this classic electrospinning, all the question arise was how you plan to scale up your system with only one needle. And I know there are companies working on this, but I think the possibility to use needleless has some main advantages. So we use it in particular in our lab, NS lab. Main parameters in electrospinning, we are classifying in 3 main points: in solution polymer preparation parameters, process parameters, environmental parameters related to the place where you are making your membrane. Polymer concentration and viscosity, the solvent volatility and conductivity, the surface tension, related to solution parameters, we think are the most important one. Process parameter related to applied voltage, the flow rate, and the needle collector distance. And then some environmental parameters like temperature, humidity, and also airflow. Of course, each changing of one of these parameters can change the morphology of the fiber you are producing, and of course you can play very well tailoring the final membrane you want to obtain. Going to the membrane sustainable preparation, now there is a lot of work starting to try to develop a new way to make membranes using a more sustainable approach. The idea is, for example, to use more greener solvent or non-toxic solvent. Here you can see the list of the most used solvent in membrane fabrication. I mainly refer in this case to phase inversion technique. Usually you can see NMP, but you can extend easily to electrospinning machine technique too. NMP, DMC, DMF are the most used solvent, which are protect solvent. So the idea is to try to change this solvent with more greener solvent, and I will go more in details later. Again, in the membrane field, we are also in a period where there is also some changing on the polymeric material we usually use. Consider that the most used material in our field is sulfone-based polymers like polysulfone or polyethersulfone, and the fluoropolymer like polyvinyl difluoride, PVDF. For different reasons, for example, now fluoropolymers, as you know, in many cases there is a lot of discussion about this possibility of release of PFAS, etc. And there is also a lot of efforts from the researchers and also companies to identify maybe some substitute that could do the job. But probably biopolymer can be one alternative, even if for several cases and in several areas is not so easy completely change material, use it for many years to new materials. However, this is the attempt, and this is what the researcher does, and also try to drive somehow the new researchers. Briefly, let me introduce briefly the concept of green chemistry, just to give an idea what we are talking about green chemistry and what is about the concept. Usually when we talk about green chemistry is about the use of a set of principles which eliminates the use of generation of other substances in the design, manufacture, and application of chemical products. And we refer to a concept that has been quite recently in the 90s by Anastas and Warner. And here you can see the 12 principles of the green chemistry. So the idea is to design chemical processes in a less polluting, more efficient, and less hazardous way. I think the principle of green chemistry, if you are talking now related to the membrane fabrication, etc., can be mainly referred to the green chemistry principle 1, waste prevention, number 5, related to the safer solvents auxiliaries, and number 7, use of renewable feedstock. To define the criteria of a green solvent is not so easy. It's not only related to the fact that the solvent is not toxic. Here there are 12 criteria that define a green solvent. If you read these, then you, at the end of this, you think that it's not so easy to say that we have a green solvent. The criteria that define green solvents are related also to the availability, are related to the price, the recyclability, the grade, the synthesis, not only the toxicity that is the first things that come in mind when you talk of more greener solvent. So to define and identify a solvent is not so easy. The idea that moved the researchers, in particular our institute, it was to the fact to start with solvent that has been already used in other fields that are proved to be greener, and then are available also on the market. So this make it easier for someone to go from lab scale to industrial scale in an easier way. Here there is some list of solvents. You can see gamma valeriolactone, butylpyrrolidone, dihydrolevoclonazone, isosorbide dimethylator, which are some of the solvents that in the years we have tested in our institute, and many other researchers done all around the world for producing a membrane. And these are also the solvent that we tested in electrospinning machine. In particular, today I will report about the use of Cyrene, which are the main problems to use these solvents in the system. As you'll see, as also in the phase inversion technique, is not just to change a solvent that allowed you to make the membrane you want. There are several parameters influence the membrane formation, which really is important to identify the right parameters. Just to show you the publication of greener solvents in the years grown a lot. I just report until 2023 in this slide, but I can already tell you that 24 and 25 the positive research on this greener solvent is increasing. This is related to more academia part, not to the industry. So this is more related what the researchers are studying. Going to one of the solvents that we also tested in electrospinning, I would like to talk about this bio-derived green solvent, because I think this is very interesting. You can say that this is a green solvent. It's produced by Circa, and it is available on the market, and present several features of interest. Usually we make usually comparison with traditional aprotic solvent like an NP, DMF, DMA, which are the most used solvent. If you see, the main differences and also advantages of Siren is the fact that in some cases is the high boiling point, 227. For some cases can be good. For example, it can be good because it can be also processed at very high temperature for some application in membrane field. Is miscible with water, so that's very good, for example, for phase inversion. And however, present some limitation, mainly related to the viscosity. If you see the viscosity, in this case, is about 14.5 centipoise. That is almost 100 order of magnitude higher than NP, DMF, DMA. And this can be a problem for different processes if you cannot, for example, heat it up your dope solution. And this is also limitation. Generally, we observe in many different type of greener solvent. In particular, I would like now to move to a specific case study that has been developed between called CNR and the Royal Society from UK. In particular, we developed this work. We made this work University of Bath with the group of Davide Mattia in Bath. And the idea was to produce membrane in a more sustainable way, using again polymer like a polyethyl sulfone, typical polymer used in membrane, by using more greener, let's say, solvent, and then evaluate the membrane performance, for example, in a water treatment process, and then also implement some machine learning, etc. Also, in a way to make faster the identification of the materials that we have been can be produced. Here again, as I showed before, I reported some of the physical and chemical properties of the solvent used. You can see the Siren. I reported again some information related to the density, flash point, boiling point, the viscosity, and also some risk phrases that is practically there is no risk, it's just irritation, but it's not a big issue. The MSO, that is also a kind of blend. We use it with Siren to produce our membrane. And then usually you have to add, for example, for electrospinning machine, you have to use some volatile solvent. In this case, usually it's use acetone, but we want to be more, let's say, safer, and we try to use dimethyl carbonate as an alternative to acetone. Then also we use two different salts. We try to compare the use of salt in the formulation of making electrospinning membrane. Of course, the salt is very important for the conductivity, and then it's very important for getting a specific feature of the final electrospun membrane. In particular, we use lithium chloride, but also we use tetramethyl ammonium bromide, which is a lot of use in literature. But however, if you see in the pictogram of the safety risk, it's quite considered it's quite dangerous. So also in this case, we prefer to use lithium chloride. After preliminary solvent test and the optimization of the solution concentration, a PES 10% solution was selected for making the electrospinning using the Elmarco machine with a needleless system. And solution you can see is a very yellow amber color and appear completely clear. Then we proceed. We use 10% of polymer mixture, different mixture of Cyrene DMSO and DMC or acetone, depending on the cases, with the lithium chloride of about 0.01%. And you can see on the right this PES membrane that has been produced. Before I want just to show you some of the results which show the use, the importance of the salt and without salt. You can see that on the top, without salt, we could observe a numerous formation of beads, even that create a lot of defect on the membrane. While the use of the lower concentration was already really beneficial, and due to the fact that increasing one side, in one case, the solution conductivity, stabilizing the electrospinning jet and promote uniform fiber stretching, therefore minimizing this bed and ensuring it's more consistent fiber morphology. We also perform a test to better evaluate the difference between the presence of two different salts, as I mentioned before, the lithium chloride and the quaterammonium salt. That is a lot of usage, and we don't observe much change in, let's say, the formation of the membrane. Only the fact that the quaterammonium salt can be quite toxic, the idea to go more greener, we focus our attention in the research of lithium chloride. Then we evaluated also the effect of the volatile solvents, in particular, as I mentioned, the dimethyl carbonate, which is and the acetone. As I mentioned before, volatile solvents play a key role in electrospinning. In fact, they evaporate quickly during the jet injection, and they solidify fibers before they reach the collector. So this prevents usually the bead formation. Dimethyl carbonate can be considered more sustainable due to the low toxicity, biodegradability, no mutagenic effects, and therefore it can be, I think, can be used instead of acetone, even if it's widely used. However, from our experience, we could observe that DMC could be an interesting. Then we also try to disperse the GO in our polymeric solution. The dispersion of GO is due to many differences, because it can give you many advantages related to the fact that it can increase the hydrophilicity of the producer membrane, can reduce the biofouling sometimes, and can improve also the water permeability to the fact that it is more hydrophilic compound. Here we report a kind of recipe. We use it, and since we are using a different solvent, we have to use for disperse the lithium chloride and GO. We made in a different phase. So we disperse lithium chloride in DMSO. We disperse GO directly in the Cyrene, and then we mix together. And PES was again 10%. Everything was done at about 70 degrees. We sonicate several times, and then at the end we obtain a very stable solution. You can see here on the left the solvent the polymeric solvent that we use. In the next slide, you can see the membrane without GO and the membrane with GO at a different concentration of graphene oxide, and you can see that the membrane looks very well. They improve a lot also the stability thanks to the addition of the GO. And we could observe also a decrease in the pore size thanks to the addition of the graphene oxide. In particular, here you can see in this picture, even at low concentration, small fibers, sometimes fibrous beads present some small beads, and these are like due to some accumulation of GO on the fiber surface. So it's very important the dispersion of the GO in the polymeric solution. The graphene concentration of 1% of GO resulted in thinner fibers respect to the 0.5, and this can be explained, for example, from an increase of the solution conductivity. Moreover, the thickness of the membrane producer and the same electrode condition decrease with higher GO content, reflecting a denser and more efficient stretched fiber mat. Again, this table provides the main parameters of the membrane produced. These are the typical process parameter that you apply, that you use when you work on electrospinning machine. So you have the electrode distance, voltage, current, temperature is practically a room temperature, and the humidity in the chamber. Consider that all these variables now I just simplify, but before arriving to the optimal condition, many different type of experiments has been carried out. What I like to show, part of that, the presence of GO slightly decrease the elongation of the break, so the mechanical strength of the membrane, had a very interesting increase of the water permeability. And this is increased with increase of the percentage of GO, and this is also strongly related to the fact that the membrane, because if you see, for example, the pore size distribution is practically the same for GO 0.5 and GO 1%, and even reduce with respect the membrane without graphene oxide from 1 to 0.6. So we really think that the fact that we have a decrease of the contact angle from 129 down to 100 in the case of GO 1% make a really big difference also in the passage of the water and then increasing the water permeability. I like just to give some conclusions. In particular, there are many efforts being carried out to make the membrane process greener by replacing the traditional toxic solvents with the greener alternative. As I mentioned before, in membrane technology, this is one of the hot topics we have at the moment. And in particular, in the selection of fabrication method, in particular aspect is also, again, is an interaction between the polymer and the green solvent. We use, for example, answer solubility to better understand the dissolution mechanism between solvent and polymer, and also to identify the optimal solvent to easily remove substitute solvent, greener solvent with a more toxic one. A series of solvent has been tested. In particular, in our, as I mentioned today, we use a Cyrene or DMC, and that's been used and showed the potential possibility to be used as a greener solvent, for example, for polyether sulfone membrane. And then the new direction for sure is going to production of more sustainable membrane fabrication. As I also showed before, in particular, we were quite obliged in the case of electrospinning machine to mix a different type of solvent to have the optimal membrane formation. But this is also something that we are using also in traditional membrane formation, like phase inversion technique. In phase inversion technique, usually you use only one solvent, NMP or DMF or DMA in the past, or just one green solvent. But because they were available on the market, we just were obliged to use this type of solvent. Now the new trend is to try now, based on the knowledge we have, to mix sure the solvent the proper way to make adapt to the membrane you want to produce. Like Jen, just let me thanks the Italian team that, of course, support all this work and the several projects we are involved where we are using a greener solvent, in particular for electrospinning. Here are some of the colleagues I would like to thanks, and thanks to you for the attention. I really hope I could give some new insight of the greener solvents for membrane fabrication. Thank you.
Okay, so let's thank you, Professor Figoli, for the very interesting talk. We got a lot of topics: membrane, electrospinning, nanofibers, green solvents, all together. So I will start with my question, and I will follow with the questions from audience. So again, I remind you, everybody who of you want to ask anything to professor or to the topic of membrane and want to contribute with some maybe idea, you're very welcome to use the Q&A session for your inputs. So my question here is, of course, related to electrospinning, because one of the methods that you mentioned, how you can make a membrane, is actually using the method of electrospinning. As I understood from your, let's say, selection of different membranes, we're talking about the microfiltration with nanofiber membranes. So how do you see the role of scaling up of this particular membranes, and for what kind of segment of market we're talking about? Because the microfiltration will definitely bring different properties than compared to nano or ultrafiltration. Yeah. So if you can comment on that a little bit.
Yes, thank you for the question. This is a question that anytime arises when we talk with companies. How you think to bring it to the market, to bring a laboratory scale up interesting results and bring it to the market. This is a very challenging question, in particular if we talk about the use of greener solvents, which should replace solvents that has been used for many years that we know that works very well. One main topic, apart of the physical properties of the solvent that you saw before, for example, one criticism that we see with the greener solvent like styrene, but not only for styrene, also for others, can be applied is the viscosity. So viscosity is really a key issue, we think, for several applications and probably also for electrospinning, and this maybe you can give more insight on this aspect. And for sure, another aspect that can limit the scale up can be the cost, because the cost usually of a greener solvent is quite higher with respect to the traditional solvent. And even if when we talk about green solvent, I mentioned before the criteria, if you remember, one of the criteria is also the availability, and the cost should be always the same. When you go to company, sometimes you have a change of this type of solvents because they are not using a wide quantity as for the traditional solvent like NMP, DMF, DMA, and this make, of course, solvent costs rise. I am expect this cost should lower more we use, and we expect more the cost going down. But this is at the moment can be a limitation. Related again to electrospinning, also referring is that I see that we have to use also, let's say, volatile solvents together to our mixture, and also to identify, let's say, volatile solvents which should very well compatible with the other solvent. And also with the polymer, it's not also an easy scale. Last things related to the critical issue, now we are talking about criticism, is about the recycling and recovery of the solvents. In many of the membrane systems production, we have at industrial scale, we have some kind of a distillation column at the end, in some cases at the end of the water treatment system. And in this case, so the recycling and recovery of a solvent you are using can be really an important task to know when you are preparing your meal.
Thank you. Maybe we can
start. Yeah, let's start with the Q&A section. I'll go ahead with our questions. So, what do you think about the role of electrospinning in terms of production of like new membranes, like new actual products, really products you see as a let's say, you could potentially see shortly in the market? What is the role of electrospun materials towards these applications?
I think this is a very good question. As I showed you before, the technology is quite easily to be adapted to the need of different application. As I showed you before, you can use polymer, but you can use polymer with some additives or fillers, like for example, in this case, I use graphene oxide. But then you can really think to use any type of fillers which could functionalize your membrane and could be able to give an added value product to the final membrane. You can think you can use nano fillers that can give you some anti-fouling properties. You can have some fillers that can give you some antimicrobial activity. You can think of fillers which can be have some responsive surface for a specific trigger you're using for giving some functionality to your membrane. So I really think that electrospinning can be a really technology that can enable to make it, because if you find a way how to disperse well your, for example, your additive or your fillers in your membrane, it can be really easy to be well homogeneous in your very well homogeneous in your system. And we are now applying, for example, for different application. We are applying, for example, to evaluate the change of the temperature in the surface, adding some specific filler that modify with the temperature to evaluate, for example, it's called concentration, temperature concentration along the membrane. That is typical problem, for example, for membrane distillation, specific membrane system.
Thanks. So another question. You talked about like criteria for solvents to be suggested or named as a greener solvents. Do you think about like what can you say about life cycle analysis? Is it taken into consideration as well?
Yes, of course. Life cycle analysis is also another tool that you can use it for better evaluate the sustainability, in this case of the solvent, but also all process on membrane fabrication. So that for sure, LCA is a valid tool. However, I think the first tool you have to use to see if it's starting from a solvent that has to be really green or non-toxic, and then of course you can speculate with different variables in the membrane fabrication or the membrane type.
Agreed.
I have another question which is related to actually align fibers and related to the membranes. And we as Elmarco, we're also getting a lot of, let's say, requests or inquiries for how we can make, let's say, how we can upscale the production of aligned fibers. So this is actually interesting also for us. So how do you see actually the combination of the purpose of aligned fibers in the membrane world, if I can generalize it like that? Did you have any?
Aligned fibers? What do you mean aligned fibers? So you mean
aligned fibers, like aligned fibers, I suppose the fibers that are going in one direction in this, layer format. Is there any, particular use of these aligned fibers in terms of filtration?
Yeah, it's actually if like, do you know any like particular applications where it's really important to think about mat, nanofibrous mat, which consists of aligned fibers. The definition of aligned fibers for electrospin usually is, let's say, more than 80% of aligned fibers if you analyze SEM picture.
Yes,
so it's probably, like rotating drum, for instance.
Yeah, probably. Honestly, I didn't use this type of fibers. I didn't have in the past to work on this. I'm thinking probably more to medical application if I have to see something that can be used this type of fibers. I think this is a good question also for you, because as a producer, I don't know if you can produce a membrane with these aligned fibers. As a membranologist, usually the main issue we have, for example, is to produce a membrane which has a very very well-defined pores all around the membrane. So having a pore size very well-defined all in the membrane, more to have, let's say, aligned the fibers. But this is one of the key issues that we have. Is not easy to solve. So if you use, for example, phase inversion technique, usually you have a random type of pore size in your surface. But to obtain a very homogeneous and very well-defined pores is one of our dream topic, let's say, copying the nature does in some cases.
Thank you.
Yeah.
Yeah.
Is it, Professor, is it correct understanding that the main purpose of blending solvents is related to the low volatility of serines? So with these co-solvents, you're actually helping, you're increasing the speed of evaporation of solvents to get dry fibers.
Yes,
is it
mainly this is one of the main key role, let's say, of, and then also the other one is the fact that, as I mentioned before, is quite viscous. So also blending with less viscous solvent decrease the viscosity and make it easy, let's say, the preparation and production of the dope solution to be used in electrospinning machine fiber production.
Yeah, thank you. Next question is related to the particles of, I think it was a graphene oxide, yeah? So what is the size of those particles that have been incorporated into the membrane?
I think it's a nano size, of course. I now don't remember exactly the size. It is typical graphene oxide. And then this is considered that this idea was just a way to prove that the nano fillers could be included in the nanofibers of the electrospinning membrane we are producing. And we also using, for example, titanium oxide nanoparticles, which has a size, for example, 20 nanometers. This is roughly the range that usually we have, and meaning that it can be really beneficial to have in the nanofiber these nanoparticles, and it's very good because they can be really in touch with the fluid you want to process. So sometimes in the membrane where you're producing, we have the membrane and these nanofibers and it is nanoparticle inside of the membrane and not directly in contact with the fluid that we want to treat. In the case of the electrospoon membrane, since there is very open structure, the facility of the fluid, of the liquid to enter in contact with the nanofiber is very high, and that makes also the properties of the membrane increase. In this case, for example, the hydrophilicity of the properties of the membrane.
Okay, thank you.
Did you observe any change in electrospinning process behavior while you were adding graphene oxide to the polymer solution? Is there any big effect of relative humidity to the process with and without graphene oxide?
Yes. We observe it very interesting change, mainly to the fact that the graphene oxide, as I show also with contact angle, other properties of graphene oxide is more hydrophilic. So of course tend to also absorb somehow the humidity from the air. So this is one effect where that for example we could observe. But generally, for what we observe, we didn't see really big changing at the end in the final membrane preparation, let's say. So we didn't observe any big influence in terms of processability of the material.
Yeah, it's a again question related to the green solvents. It is obviously very interesting topic. So you mentioned that the green solvents are obviously very expensive. So the question is, how will they be particularly used compared to other solvents? Isn't it a major problem? Do you think it will be overcome somehow?
You mean the cost related of the green solvent, let's say? Yes, I think so.
You see this as like the main barrier at the moment to have these greener solvents being more common in industry.
Yeah, I think the main issue is probably from a company, at least what we observe, is more from a company that has already a own process line in membranes production to change with the new solvent, then has to be somehow redesign their process system. This can be a main limitation, also of course related to the cost, but also related to the process design. Also, in case you want to, for example, you have to heat it up your dope solution to make viscosity lower, etc. Otherwise, we had an example, for example, in North of Italy, there is a company that started from zero to make a new process, and they even had, let's say, higher cost at the beginning related to the green solvent. They decided to invest on this aspect. I think what I expect, as I mentioned before, increasing the number of people working on greener solvent, it should bring the lower down the price of the greener solvent we are using. So it's a question of demand and on the demand.
So we are a bit tough on time, as always, with a lot of questions. Very interesting topic, obviously. So let's go ahead with the two more questions, and then let's summarize today's talk. What do you think, what's in your opinion is the most critical research direction in sustainable electrospinning for the next, let's say, 3-5 years?
Yeah, I think that, as you mentioned before, is the fact that to find, let's say, greener solvent can substitute the traditional one. I think this is the most useful. I think the one I mentioned is quite interesting. Siren, there are other types that we tested already, but I think this can be the main limitation. Also, in terms of greener, let's say, more volatile solvent, it can be also an issue. I think can be probably the issue I see, not talking about cost and everything at the moment. No, I think this is scientifically, I see this as a main issue.
Actually, a question I saw before, but I just don't see it right now. But it was also related to the definition of the green solvent. Is solvents like ethanol or acids or water considered to be green solvents or not? How do you see that?
Yeah, I take water. I mean, considering that now we're going to scarcity, so probably it will be not anymore considered green soon, because it's considered the scarcity, in particular in Italy. Now we are facing drying time, so this can be an issue. But good question. This is what is reported. Let's say consider the definition of green solvent. So that's the reason we talk sometimes non-toxic solvent or more sustainable solvent than really green solvent.
So let's go through the last question. I think now, and it's a very practical one, I would say. As it was mentioned, sustainable solvents or solvents presented in your presentation, we also have the same experience that more sustainable or less toxic you want to be, usually you need to work with solvents with a high evaporation rate. So obviously it leads to high concentration of retained solvents or residual solvents in nanofibrous layer. What is your experience? Is there any special post-treatment you need to apply to get rid of this, to remove the residual solvent?
Yeah, this is a very interesting question. Usually we use, let's say, hot water as a first step, as a post-treatment to remove, let's say, solvents. But then if you want to really remove traces of solvents, and then you have to even go to some heater with the vacuum to really remove some of the residuals. So sometimes that's also play an important role, the type of solvent you are using and the interaction of the solvent with your polymer. So there is not really a general answer on this, but this is an issue. At the end, you want to remove completely. In membrane fabrication, usually you have going through many baths that has the you rinse the water with hot water and then drying the membrane and then to get the membrane without any traces of solvent. Yeah.
Okay, I guess that's it for today. Thank you very much for your contribution, and I'm sure there are still some questions that hasn't been answered, but please contact us directly, or we will summarize the question and answer them after this session. So thank you very much for following us, and then still stay with us for the next sessions, which are already planned in October and November. And yeah, thank you for today, and stay spinning.
Yeah. Thank you very much for your attention. Thank you for very interesting talk and good questions. Thank you very much, all.
Thank you very
you.
much.
Bye-bye.
See you. Bye-bye.
Goodbye.